Hello everyone, I am Mayuri Hawaldar, Assistant Professor of Physics at Rajarshi Shahu Mahavidyalya, Latur. Today in this video, I am going to represent the point is Birefringence. Actually, Birefringence is also called as double refraction. In that, we are going to present topic Introduction, what is the history behind the Birefringence, what is the polarization, type of a crystals like a isotropic crystal and isotropic crystal, then the double refraction, then the O ray and the E ray, the negative crystal and the positive crystal. Last is the optic axis. First of all, we have to understand the definition of a birefringence is that it is the optical property of a material having the refractive index, and that refractive index depends upon the polarization and the propagation of direction of light. What is that? It is the optical property of a material having the refractive index, and that refractive index depends upon what? The polarization and the propagation of direction of light. What is mean by the double refraction? You already listen about the reflection and the refraction, but not about the double refraction. It is also called as a birefringence. Then double refraction is double refraction of a light in a transparent molecularly ordered material which is manifested by the existence of orientation different in refractive index. What happened? We have to understand the history. What is the history behind the birefringence is that actually the Danish scientist Rasmus Bartholin in 1669, he take a paper like a paper and draw a dot on that paper and put the calcite crystal on that dot. He draw one image of dot. If he put the calcite crystal on that dot, then he observed the two images of that dot instead of one image. Actually, he draw only one dot. When he put the calcite crystal on that dot, he observed the two dots instead of one dot. Then from that, he observed the phenomena of double refraction. Now we commonly called as a birefringence. Then next is polarization. In the double refraction phenomena, what happened? Why we here explaining about the polarization? Actually, double refraction phenomena is observed only in the anisotropic crystal. Anisotropic crystal is that the crystal which has the different properties in different direction. When we light passes the light from one side, we get some properties. After when we change the direction of a passing of light, then we get another properties of light. That property and these properties are different. That crystal we called as an anisotropic crystal. When we incident the light in that anisotropic crystal, okay, the light is unpolarized light. We transmit the unpolarized light like this unpolarized light, the light which has infinite directions. What about the light? We can consider the light in the electric field manner. The electric field has two vibrations. First is a parallel vibration, another is a perpendicular vibrations. Means two vibrations are combined together, that we called as a light, electric field in this terms of a light. Okay, this unpolarized light is passes from the anisotropic crystal. That light splits into two rays, that is O ray and E ray. O ray is a ordinary ray and E ray is a extraordinary ray. O ray is a parallel vibrations of a electric field, and the extraordinary rays is a perpendicular vibrations of the light or electric field. Means when we incident the unpolarized light from that anisotropic crystal, the light is split into the two vibrations like a parallel vibrations and the perpendicular vibrations. But polarization is a concept. Here is, if suppose there is an unpolarized light and I have a vertical polarizer like that, this is the transmission axis of the polarizer. Okay, when I transmit the unpolarized light by that polarizer which has a vertical axis, when I transmit the unpolarized light by this polarizer, we get only vertical vibrations. We get only vertical vibrations. Other than this vibrations is blocked by that polarizer. This light we called as a polarized light, means we get only one directional vibrations. This light we called as a polarized light, and this phenomena we called as a polarization. In double refraction phenomena is also we can consider as a polarization phenomena. When we transmit the unpolarized light by the calcite crystal or anisotropic crystal, we get the light in splitted form, means E ray and the O ray. E ray is also polarized light and O ray is also polarized light, means we get the polarization phenomena in that double refraction phenomena. Okay, next is types of a crystal. I already said there are two types of crystals. One is a isotropic crystal, another is a anisotropic crystal. What is the theory behind the isotropic crystal? That isotropic crystal and the anisotropic crystal is defined by the properties of light, where we changes or where it changes when we transmitted by that crystals. Okay, isotropic crystals means the crystal which has same properties in different directions, means when I transmit, this is a crystal, isotropic crystal, when I transmit the light from this side, we get some properties of light like a velocity, electric conductivity, or what it may be, refractive index, some properties of light. Again I transmit the light from this side, again I get some properties of light, but these properties and these properties are same, then this crystal is called as a isotropic crystal, means we get the same properties in different directions. Isotropic crystal is a crystal in that the periodic arrangement of atoms is same in all directions. When we transmit the light any side, we get the same refractive index, we get same velocity, we get same electrical properties. Okay, but not about the anisotropic crystal. Anisotropic crystals are different than the isotropic crystal. Here are isotropic crystals, example is glass, table salt, or sodium chloride. Okay, next, anisotropic crystal. Anisotropic crystal is a reverse process of a isotropic crystal. That means suppose I have an anisotropic crystal, when I incident the light from this side, we get some properties of light. Okay, again I transmit the light from this side, we get some properties of light in this side. These properties and these properties are totally different because there are a periodic arrangement of atoms in different directions. Because of that only we get different properties of light in different directions. That crystal we called as a anisotropic crystal. There are examples of anisotropic crystal is quartz, calcite, and tourmaline. In the calcite crystal or quartz crystals or tourmaline, we can observe the phenomena of double refraction only. But there is one point, that is the optic axis. In the next slide, I will explain about the optic axis. Okay, only optic axis, from that optic axis, we cannot observe the double refraction phenomena. Only except optic axis, we get the double refraction phenomena in the calcite crystal or anisotropic crystal. Next is double refraction. I already said what is mean by the double refraction. Double refraction is that the light is transmitted in the anisotropic crystal. The light is split into two rays, that is E ray and the O ray. O ray is an ordinary ray and E ray is an extraordinary ray. That phenomena we called as a double refraction. Next, there are some images of double refraction or a birefringence. Here there is one pencil and on that pencil we put a calcite crystal. When we put the calcite crystal on that pencil, we get two images instead of one image. That phenomena is called as a double refraction or a birefringence. Here is also second image of a birefringence. Next, what about the E ray and the O ray? Here is a calcite crystal. If I incident the unpolarized light is defined by the dot and the arrow. Arrow represent the perpendicular vibrations and the dot represent the parallel vibrations. Okay, then the light is split into two rays when it transmitted or when it touches from the calcite crystal. Unpolarized light is transmitted to the calcite crystal. The light, single light or single line is split into the two lines or two rays, that is the E ray and the O ray. Okay, then next is a negative crystal and the positive crystal. Negative crystal and the positive crystal is a type of anisotropic crystal. That means in the negative crystal, the E ray, the refractive index of E ray is less than the refractive index of a O ray. But in a positive crystal, the refractive index of O ray is less than the refractive index of a E ray. We in the last video I already said the relation between the density and the refractive index. Okay, if the density of any material is increases, then the speed of light is decreases. Okay, or if we increase the density of any material, then speed of light is automatically decreased. Here the E-ray refractive index is less, that means your speed is more in the, or E-ray speed is more than the O-ray. Here a refractive index of O-ray is more, that's why the speed is less. Then also this is a positive crystal. In the positive crystal, the O-ray refractive index is less than the E-ray. Here means speed is also changed. Then last concept is a optic axis. In the last time I said that in the anisotropic crystal, except optic axis, we observe the double refraction phenomena. But what is that the optic axis? Optic axis is the line join two bluent corners. The two bluent corners means here is one calcite crystals. Okay, three angles made in equal angles. That corner we called as a bluent corner. And suppose this is a bluent corner and this is a bluent corner. Suppose this is a bluent corner. Here are three angles are combined here, and each angle are equal in angle, like a 120 degree, 120 degree and 120 degree. Suppose this is a bluent corner, has a equal angles, and this is also the bluent corner. These two bluent corners bisect by one line. This line we called as a optic axis. If we transmit the light by that optic axis, we not get, or we cannot observe the double refraction phenomena. We get properties as like a isotropic crystal, means your unpolarized light or your simply light is not split into E-ray or O-ray. Okay, this is the all about the double refraction phenomena. Thank you.